Hello, welcome to this video on the convex lens. In this video we will discuss some definitions and we will also discuss how to draw a ray diagram. So let's discuss some definitions that you need to know. The center of the lens is called the optical center, and we give it the letter C. So C stands for the optical center. Now, this straight line here that passes through the center of the lens, this is what's called the optical axis. Now, this point here with a cross, this is what's known as the principal focus, and we give it the letter F. So F stands for principal focus. There is actually another focus here on this side, and we give this point here, or this focus here, the letter F and then a little line or dash. So this focus that we're calling F dash, this is what's called the secondary focus. And the distance between the principal focus and the optical center, this is called the focal length. Okay, so this distance here, let's call it F. F is equal to, or it is the focal length. You probably guessed that actually this distance between the secondary focus and the optical center is also equal to F. Now, let's consider what happens when light rays reach the lens. So let me change color. Say a light ray from a very distant object, maybe a star. Draw that again. Reaches the lens like this, and this light ray is parallel to the optical axis. So let me write that. This ray is parallel to the optical axis, or just axis. Hopefully you remember from maths that if two lines are parallel, they will never meet. Okay? So what we're saying is that this line here, representing the ray, the incoming ray, and the optical axis, they will never meet because they are parallel. Now, such a ray, when it reaches the lens, it changes direction. So the lens, it bends the ray like this. And you can see that the ray bends towards the principal focus. If I draw another ray that arrives at the lens, again parallel to the optical axis, it will also bend towards the principal focus. Let me draw just one more ray in. Okay, so again, if we have another ray that is parallel to the optical axis, it will bend towards F, capital F. To summarize, all rays that reach the lens traveling parallel to the axis will bend towards the principal focus. And we say that these rays, these parallel rays, we say that they converge to the focus. Now let's discuss what would happen if a ray were to arrive at the lens in this direction. So you can see that this ray, I've drawn it from the secondary focus. Okay, F dash. It turns out that a convex lens would bend or cause the ray to change direction so that the ray would travel parallel to the axis, like this. Similarly, if we had a ray traveling like this, it would also be bent by the lens and travel once again parallel to the axis. Okay, so all rays, let me draw one more here, all rays that travel through the secondary focus and reach the lens will end up traveling parallel to the optical axis, like this. One other thing you should know is that if a ray was to travel like this, if it was to travel towards the center, the optical center of the lens, then such a ray actually does not change direction. So you see I've just drawn a straight line there because this ray, it is not bent by the lens. Now let's see how we can apply all of these concepts to work out where an image would form. So we have an object here which is an arrow. Okay, an arrow which is pointing up. And what we are interested in is the rays, the light rays that start from the top of the arrow. What will happen to those rays once they pass through the lens? To answer this, we need to use the concepts that we have covered so far in this video. So, a light ray from the top of the arrow that travels parallel to the axis. Remember, such a ray is bent by the lens and travels through the principal focus, like that. Now let's consider a ray from the top of the arrow that travels through the secondary focus. Do you remember what happens to such a ray? Such a ray is bent by the convex lens so that it emerges parallel to the axis on the other side of the lens, like this. Let's draw one more light ray from the top of the arrow. Let's draw a ray that passes through the center of the lens. Do you remember what would happen to such a ray? Such a ray would not bend and would travel straight, like this. And what you can see is that all three of these rays, converge to this point here. And so this is where the image of the top of the arrow would form. Notice the following properties of the image. If you look at the size of the image, this arrow here, you will see that it's smaller than the size of the arrow in the object. Okay, so we say that the image has been, or it is diminished. So it's smaller than the object. Also, notice that the arrow here is pointing down, whereas the arrow in the object is pointing upwards. Okay, so here this arrow is pointing up, but here the arrow is pointing down. So we say that the image has been inverted. And finally, the last property you need to know about this image is that it is a real image. Okay, we know it's a real image because these rays of light from the object, they converge to a point, meaning we could form this image on a screen. Okay, so that makes it a real image. In our next video on the convex lens, we will discuss how changing the distance between the object and the lens, how that will affect the image that is formed, the properties of the image that form. Thank you for listening.